Hello and welcome to Aakash BYJU'S. This is your friend and mentor Mrinal, and we are back again with another session on photoelectric effect and matter and waves. So in the last session we discussed about photoelectric effect in theory. Now I want all of you to quickly come in and let me know, because we have a very interesting session stored for you today. So in today's session we are going to solve questions based on the concept that we had studied yesterday, and we are going to also solve some previous year's questions. So it will give you a complete idea as in how to learn the concept and then how to apply it. So I want you guys to tell me in the comment box, am I audible? Am I visible? Audio, video, all okay? Hello Anurag, hello Akhtar, I have Sujal, Rahul Pandey, good evening. As usual, Captain Jack Sparrow, I don't know your name. If you could just mention your name, it will be better. Shubh, good evening. Okay, Sujal is asking, sir, is it applicable for NEET 2? Yes, Sujal, it is applicable because we will be doing previous year's questions of JEE, but as far as the equation, the concept and the questions are concerned, more or less, the questions that we are going to take care today will be of JEE Mains level. And if it's of JEE Mains level, you know that it's also important for NEET, because you know that both the papers are now being set up by the same entity, which is your NTA. Okay, so okay, Captain Jack Sparrow, naam mein kya rakha hai? Okay, I'll call you with the same channel name. Okay, Namaste Seema, Manav. Hello, good evening, I'm good. I hope you all are good as well. So chalo shuru kare. Now, today's session is going to be like a revision session for all of us. So jaldi se aapko kya karna hai? Take out your notebook, take out your pen, because we are going to solve some wonderful questions today. Hello Prem. So yes, if you are all ready, can you just give me a thumbs up with your notebook and pen, because you will be solving questions with me. So I'll just provide you some hints. I'll help you how to solve, okay? But solution आपको खुद से करना है, और मेरे से पहले करके you need to tell me in the comment box कि किसने सबसे पहले किया है. I'll try to keep the language as mostly English. So ठीक है, चलिए शुरू करते हैं. Okay, प्रेम, मानव, अक्षय, शुरू करें. Shall we start? All ready? Just give me a thumbs up, guys. Okay, chalo. Let's start. Let's start. First question of today's evening, and this is the previous year's JEE Main question. Okay. Okay, Karthik, hi sir. Hello. Okay, Sujal, we'll do other chapters also. Don't worry, Sujal. Okay, चलिए इस क्वेश्चन पे कंसंट्रेट करते हैं और जल्दी से इस क्वेश्चन को फोड़ते हैं. How much time? In less than a minute. Ready? देखिए. The question says the stopping potential V naught in volts as a function of frequency of sodium emitter is shown in the figure. So you have a graph wherein इन्होंने एक ग्राफ बना दिया है किसका? स्टॉपिंग पोटेंशियल और फ्रीक्वेंसी का. All right. The work function of sodium from the data plotted in the figure will be, so we need to find what? The work function. Cool. Planck's constant given है और इलेक्ट्रॉन का चार्ज भी given है. All right. तो चलिए, let's start. Let's start. Guys, you have got four options. Option A says 1.95. Option B says 1.82. Option C says 1.66, and option D says 2.12. Now for all these questions, which are previous year's questions of your main exam, how do you attempt it? You need to understand the information that is given in the problem. Identify the target. Okay, तो इसमें हमारा target क्या है? इसमें हमारा target है work function. Information क्या है? Information हमको ये graph दिया हुआ है. Alright, the graph is given as an information. From this information, we have to find the work function. Now, the moment you think about work function, what comes to your mind? What comes to your mind? Work function. सोचिए, work function क्या होता है? Work function would be that minimum energy requirement for the electron to come out of the surface, है ना? Right? क्या था work function भाई? एक metal surface लिया हमने, electrons were there, right? And now you are giving some radiations, so photons are coming. So the minimum amount of energy required so that you can take this electron out of out of the metal surface. Correct? To eject the electron out of the surface. चलिए सुधांशु ने आंसर भी दे दिया. He is saying it's B. Swastika, Karthik, good evening. Let's see. अगर आपको ये solve करना है तो जल्दी कीजिए. Come on, because I am going to start solving it now. Okay? अख्तर, आपको लग रहा है it's D. Let's check it out. तो 3 important information in the question. क्या क्या है? एक h का value दिया हुआ है, E is given to us and a graph is given to us. Now, when you look at this graph, the point from where this photoelectric effect is going to start, वही होगा ना हमारा work function. Corresponding to that, क्या frequency? What is the frequency? 4 into 10 to the power of 14. मतलब threshold frequency is given, or threshold frequency is the minimum value of frequency from where the photoelectric emission started, है ना? Correct? Okay. तो क्या हो जाएगा threshold frequency? कितना है? 4 10 to the power of 14 hertz. 14 hertz. ठीक है? Okay. और हमको पता है, what do we know? Work function is the minimum energy. So अगर हमको frequency पता चल गई, तो what will be the minimum energy? Phi will be equal to h times of this new threshold, है ना? Correct? ठीक है? ये तो पता है और ये given है. अब आपको क्या करना है बताइए, क्या करना है? You can just write it as h is 6.63 into 10 to the power of minus 34. अब देखिए, this is given in joule second. You need the final answer in electron volt. तो इसका भी ध्यान रखना है. Frequency कितनी आई है सर? 4 into 10 to the power of 14, है ना? Divided by, now this is in joules. So if the answer would have been in joules, we would have gone with this. Okay, I can see many people answering. Anjani, Maria, Akshay, Martin, Genius, Karthik, good. Most of you are aligning towards which option? Option B. So just hold on to your horses. The moment I solve it, I'll also reveal the correct answer, and if it is correct, then well done, good job. Let's check it out. कि आपने जो आंसर दिया वो correct है कि नहीं. Now once you have got this value, but this is in joule, तो ऐसा गलती आप बिल्कुल मत कीजिएगा. Don't make this mistake in a hurry burry कि इसको calculate करके इसको answer put कर दिया. Don't do that. Okay? This is in joule. You need to convert in form of electron volts. तो क्या करेंगे हम? Divide कर देंगे 1.6 into 10 to the power of minus 19. है ना? ये इसीलिए दिया हुआ था बच्चों. Correct? Okay? The moment you do this, you calculate, what do you get? 1.66 electron volts. 1.66 electron volts. This is what you should have obtained. I'm sure most of you would have got the same answer that I have got it. और कौन सा option correct है? अरे रे कर दी ना थोड़ी गलती आप लोगों ने. Okay? So which option is correct? Option C is the right choice. C is the right choice. And I'm sure most of you who got it B, probably आपने वो electron volt वाली चीज नहीं देखी. See, all the options are given in electron volt. So this is something where you get trapped after knowing the concept. See, you knew the concept, you knew the formula. Still, they trapped you where? In this conversion of units. समझ में आ गई बात? तो जब भी हमको ऑप्शन देखना है, whenever we are looking at the options, we'll also check कि कौन से units में दिया हुआ है. Okay, this is a very important learning from this question. ठीक है? Is it okay? Yes, Captain Jack Sparrow got it right. C, good. Good, well done. Okay, all right. Ready for the next question? ये question समझ में आ गया सभी लोगों को? Give me a thumbs up if you got this. Did you understand your mistake, guys? For those of you who did not get it right, did you understand your mistake? Can we go ahead? Just give me a thumbs up and we'll go to the next problem. Again, a very interesting problem coming up. और आपको identify करना है, because you need to understand in how many ways can an examiner try to trap you. और अगर आपने सारे तरीके देख लिए, in whatever way they can ask you question, if you have cracked that code, then well, no question is going to be new to you. All right, okay, let's go ahead. Second question coming on the screen right now, and be ready. Be ready with your notebook and pen. Okay, so this question, the question says, the electric field of light wave is given by this expression. Okay, wow, this expression looks quite complicated at the outset, isn't it, right? I'm not even going to read it out, but you know that when we deal with photoelectric effect, they can give you the energy associated with the photons or the total energy in any of these terms. Sometimes, because you know light is what? Light is nothing but an electromagnetic wave. So sometimes they will give you an expression of electric field and sometimes they will give you an expression of magnetic field. What you have to do? You need to identify omega, because आपको क्या चाहिए? Somehow if you know the frequency, you can write E is equal to h nu and you can find the energy associated with that particular radiation, isn't it? Correct? So you see, you have got this expression, and this light falls on a metal plate of work function 2 electron volts. So phi is given to us. All right. The stopping potential of the photoelectrons is, we need to find the stopping potential of the photoelectrons. You have got 4 options and you can see all 4 options are in volts. Okay? Let's start. Let's see who gets the first, who is the first one to answer and who is the first one to answer it correctly. Okay. First thing, always what we do is, we'll always note down the things which are given to us. Okay? Oh wow, Swastika, you have already got the answer, but in electron volts. Now understand that we want stopping potential in terms of volts. ठीक है? अब देखते हैं if you got it right or not. So from this expression, you can see that this is like a sinusoidal wave equation, correct? है ना? ये देखा हुआ है. Alternating current में we have seen this type of an expression. E is equal to E naught sin omega t plus or minus kx, ऐसा कुछ equation पढ़ा था ना wave में, right? Okay. So whatever was multiplied with t, वही तो omega होता था. So in this case, this is what? Our omega. All right. The moment you have identified the value of omega, you know that frequency is going to be equal to omega by 2 pi. है ना? Frequency is going to be equal to omega by 2 pi. At the end हमको चाहिए क्या? We need the value of stopping potential. You know, value of stopping potential is going to be equal to what? Stopping potential, that is EV naught, is going to be equal to KE max. है ना? यही तो होता था. और KE max, what was the value of KE max? Photoelectric equation, KE max is E minus phi. See, phi is already given to you in electron volts. If you are able to find this value of E, correct, you get what? You get KE max, and KE max is equal to EV naught, and then you need to convert it in form of electron volts. ठीक है? Okay? Okay? तो अब क्या करेंगे हम? What we are going to do? We have got the value of the frequency. Frequency is here. Now what we can write? From frequency, can I get the value in terms of lambda? So what will be the value of lambda? Lambda is going to be equal to C upon nu. Why did we get wavelength? We have frequency. Why did we get wavelength? Why? Because this is given in the question. That energy in terms of lambda is 12375 divided by lambda in angstrom. So we need to get the value of lambda in angstrom. If you substitute this value, which is 2 pi times 6 into 10 to the power of 14, 14 divided by 2 pi, you know 2 pi gets cancelled out, and you have the value of frequency as 6 into 10 to the power of 14. Okay, C कितना होता है? 3 into 10 to the power 8 meters per second होता है ना, right? Divided by 6 into 10 to the power of 14. What do you get? You get 5000 angstrom. Got it? Now what about energy? This E we want, right? So E is going to be equal to what? 12375 as per the question. 12375 divided by the value of lambda in angstrom, so 5000. All right, what do you get? 2.475. 2.475 in terms of electron volts. देखिए, this is giving you energy in terms of electron volt. So E is 2.475. Work function is 2 electron volts, which means maximum kinetic energy. How much is the maximum kinetic energy? It's going to be equal to E minus phi, which is 2.475 minus 2, correct? That's going to be equal to 0.475 in terms of electron volts, correct? So what is the value of the stopping potential? This was equal to what? This KE max was also equal to E V naught, and V naught is the stopping potential, है ना? चलो यहाँ solve कर दें. Shall I solve it here? Okay. तो क्या हो गया? V naught is equal to 0.475 divided by E in terms of electron volts. So you see, what do you got? in terms of volts, 0.47 approximately, which is nearer to 0.48, है ना, जो किसके almost close आ गया, 0.48, है ना. Okay, got it? What do you get? What do you get? What do you get in this case? First find out the value of frequency, वहां से लैम्डा निकालिए, get the value of lambda, वहां से एनर्जी निकालिए, ये इक्वेशन दिया हुआ है, get energy from there, apply this formula, E you have found out, phi is already given, get the value of KE max and understanding that KE max is equal to EV naught, काम खत्म. All right, all done and dusted. Which option is correct? It's option A. Yes, that's right. Option A is the right choice for this particular question. ठीक है? Okay, got this clear? Okay. हाँ, yes sir, but generally lambda 10 to the power of -10 में दिया हो तो न्यूमरेटर में, see it's an approximation, ये कोई exact value नहीं है, but when it's given in the question, आपके इस question में ही उन्होंने दे दिया था, so we are going to use this particular expression. If nothing is given, you can stick to the general formula, ठीक है, 12400, yes I totally understand, मैंने आपको कल ही बताया था, but when nothing is given, then you are going to use it. इससे क्या हुआ, आपका calculation easy हो गया, so that you are able to hit to one particular value. Got it? Okay, cool. चले आगे, चले आगे. Shall we go ahead? Ready for the next question, guys? Okay, here it is. Next question. So you saw that energy can be given in different ways. They can give you the energy in terms of an expression in terms of sinusoidal wave, and in the last case it was given in terms of electric field. What about this one? The question says the magnetic field associated with light wave is given at the origin by B is equal to B naught, and this expression which I am not going to read it again. So now they have given you an expression in terms of what? In terms of magnetic field. If this light falls on a silver plate having a work function, देखिए आपको फिर से work function दिया हुआ है, what will be the maximum kinetic energy of the photoelectrons? KE max is what is asked. All right, KE max. KE max. KE max का formula क्या होता है? KE max is equal to E minus phi. Got it? Phi is directly given. KE max is what I need to find out. Somehow I need the value of E. Correct? कैसे निकालेंगे? How do I get it? This seems to be B is equal to B1 plus B2. ऐसा कुछ लग रहा है. There is some kind of a superposition involved. There are two expression, there are two sign functions. ऐसा लग रहा है, right? Seems complicated. थोड़ा सा लग रहा है, right? Okay. इसमें से हम कौन सा value उठाएं? Which value we should take? For maximum kinetic energy, see, for maximum kinetic energy, इन दोनों waves में से आपको कौन सा लेना चाहिए? This is the decision that you need to take. As simply as that. Okay, now these are all previous year's question. You can expect similar thing over here. Now here is the decision making that is involved. What some people will do, if their concept is not very clear, what they are going to do is they are going to calculate with this, and they will get it wrong. ठीक है? You need to identify कि इन दोनों में से कौन सा expression हमको choose करना है. Okay, B1 or B2. So just tell me in the chat box, should it be B1 or should it be B2? Just type B1 or B2. Okay, just type B1 or B2. Corresponding to maximum kinetic energy, which one should come into picture? B1 or B2? B1 or B2? कौन सा आएगा? कौन सा आएगा? B2. Because when you look at the expression, this will be omega. And when you compare it with omega of B1, you can certainly see omega is greater in the second case. Omega is greater means what? Frequency is also going to be greater. And if frequency is greater, it means energy will be more. So corresponding to maximum kinetic energy, and again I'm repeating it, corresponding to maximum kinetic energy, you need to take that omega, ठीक है, जिसके लिए value energy का ज़्यादा आए. Yes, B2, Prashanna, very good. Swastika, good. Now the moment you have identified that, आपको मिल गया value. अब यहाँ पे now you need to use your brain little bit, ठीक है, because they will try to trap you up in all this. हमको पता है frequency, just now अभी किया ना, frequency is equal to ओमेगा बाई 2 पाई। अब यहां तो मुझे पाई जैसा कुछ दिख नहीं रहा है, बट 6.28 कैन बी अप्रोक्सीमेटली रिटन एज व्हाट? सी, पाई का वैल्यू क्या होता है? 3.14 होता है ना। यू कैन राइट इट एज 2 पाई इंटू 10 टू द पावर ऑफ 7 c. Everything that is multiplied with this t is your value of omega, right? Okay, तो चलिए अब तो कहानी खत्म. What do we get now? 2 pi 10 to the power of 7 c divided by 2 pi. This is your value of frequency. No problem. This gives you 10 to the power 7 c. और ये c लिखना मत भूलना भाई. Don't forget c, okay? Why? Because c is the speed of light. So you need to plug in that value also. Now I know E is h nu, और main equation क्या है? Ke max, which we have to find, is equal to E minus phi. Phi is directly given to us. Correct? Yes. So what we can write? H. H क्या है value? 6.6 into 10 to the power minus 34. 6.6 into 10 to the power of minus 34. Okay, cool. And nu is 10 to the power 7 and c is 3 into 10 to the power 8. 3 into 10 to the power 8. Now is this in joule or is this in electron volt? बताओ. इसको h को किस में लिया आपने? You have taken it in joule, right? Yes. joule में लिया आपने. Okay. Yes, thank you Karthik, but just concentrate on this. Just concentrate on this question. This answer that you have got, is it in joule or is it in electron volts? It's in joule, right? So you need to convert it in electron volts. क्यों? ये भी तो दिया हुआ electron volts में. और final answer is also in electron volts. So we need to convert it in electron volts. Joule से electron volts में how do you convert? Divided by the charge on an electron, है ना? Divided by 1.6 into 10 to the power of minus 19. Very good. Good job Swastika. Well done. Okay. So क्या करेंगे? 1.6 into 10 to the power of minus 19. थोड़ा सा calculation oriented है, but if you take the approximation, you can easily deal with this mathematics. Okay? थोड़ा approximate करके you can cut it off. Now, what you have got? This will give, I'll just write down the value. Once you calculate this, this will give you around 12.37. 12.375 electron volts. ठीक है? This is what you get. Now, इसमें put ही तो करना है. 12.375 minus 4.7. So everything in terms of electron volts. What do you get? 7.765 or 675. 675, right? 7.675 electron volts. और ये क्या है अपना? This is your kinetic energy. Got it? बन गया ये? Easy? Okay? ठीक है? ये कौन से ऑप्शन के नजदीक है? It is nearer to which option? Check out the option again. What you have got? What you have got? From here, maximum kinetic energy किसके corresponding होगा? जिसका ओमेगा ज्यादा होगा. We have identified कि इसका ओमेगा ज्यादा है, right? B2 का. Then we calculated and we got this value, which is closer to which option? Option A. किसके close है? Option A. Now this is also something that you need to learn. Okay? Sometimes in questions like these, you won't get exact values. So you need to take which one? The nearest value. Okay? The nearest value in the option, that one you have to take. So don't make a mistake. ऐसे confuse नहीं होना, अरे यार अब क्या करूं? ये तो कुछ और ही आ गया. It's something else. What I've calculated is something else, and what is given in the question is something else. And you look at the values. अब देखो कितने different values हैं, right? Correct? So approximately if you would have calculated 7 point something, you see, okay, one option, that's it, done and dusted. Got it? All right. Cool. Moving on to the next question. Next question, again a very interesting question coming your way. So if you have understood the concept of photoelectric effect yesterday, these questions are going to be super easy for you, and trust me on that, these are previous year's question. So if you are finding them easy, it means that you are on the right track. अगर आपको ये आसान लग रहा है, क्योंकि ये आसान है, इसका मतलब you have understood the concept. Okay? So just take that confidence. Got it? Okay? Let's do this problem. The question says, surface of a certain metal is first illuminated by a light of wavelength lambda 1, 350 nanometer, and then by a light of wavelength lambda 2. It is found that the maximum speed of photoelectrons in the two cases differs by a factor of 2. Okay, the work function of the metal in electron volts is closer to. बताइए इसमें क्या निकालना है हमको? Work function निकालना है भाई. We need to find the value of phi. And also you have been given an expression of energy in terms of lambda, that is 1240 by lambda in nanometers. So they are giving you a hint, okay, to use this expression and to find the energy. Now roughly speaking, which photon corresponding to which wavelength do you think is going to have a greater value of energy? We know this formula, E is equal to h nu is also equal to hc by lambda. So you see, more the value of lambda, lesser will be the energy. अब बताओ, lambda 1 बड़ा होगा, lambda 1 के corresponding, if I call this as lambda 1, lambda 1 के corresponding energy ज़्यादा होगा या lambda 2 के corresponding energy ज़्यादा होगी? More is the value of lambda, lesser will be the value of energy, which means energy corresponding to lambda 1 will be greater. So can I say that E1 will be greater than E2? एक बात समझ में आ गई? ठीक है? Got it? Got this one point clear? कि energy corresponding, देखो energy का relation of energy with lambda is E is equal to hc by lambda. H और c तो constant है ना भाई, right? So you know that greater is the value of lambda, lesser will it be in terms of energy. तो lambda 1 is 350 and lambda 2 is 540. दोनों में से बड़ा कौन सा है? 540. तो 540 का एनर्जी कम होगा. Got it? Okay. अब हमको निकालना है क्या? वर्क फंक्शन. चलो, tell me which of these options are correct. चलो, let's solve this. Come on. Now you know the total energy which is coming. Even if I go with a basic idea of energy conservation, what I can write? That the total energy which we have got, that is hc by lambda 1. Chalo, hc by lambda 1 will be equal to how much? Because in both the cases photoelectric effect is happening, so you can't say that that there is one particular wavelength corresponding to which electrons are not coming out. No, that's not happening. Why? Because in the question it has been mentioned कि जो lambda 1 है, for which corresponding to which the energy is more, the velocity is also supposed to be higher, right? है ना? And जिसके लिए energy कम है उसकी velocity भी कम होगी, obvious है. Because this energy is what is getting converted into kinetic energy, na boss? Are you getting it, right? Okay. So hc by lambda 1 is equal to, can I write, is equal to half m 2v squared plus 5. Correct. Let's say this is my equation number 1. दूसरे के लिए क्या होगा? hc by lambda 2 is equal to half m v squared plus 5. Correct. Okay. Now if I take this phi on the other side, how it is going to look like? I'll just readjust things, okay? This will be minus phi. This is how it is going to look like. Okay, ठीक है? This is our equation number 2. चलो, let's divide this. कर दिया divide. क्या होगा? What will happen? ये half mv square, ये everything will get cancelled. On this side you are going to get 4. What do you get on the other side? hc by lambda 1 minus 5 divided by hc by lambda 2 minus 5. ठीक है? Now from this you know the value of lambda 1, you know the value of lambda 2, rearrange and get the value of phi. Phi आपको निकालनी है, okay? Just rearrange and get the value of phi. This is till where the concept was involved. अब इसके बाद तो आपको phi निकालना है, that's it. Only one thing which is unknown is phi, okay? So just solve this and get the value of phi. क्या आएगा phi का value sir? Approximately again 1.8 electron volts. Okay, 1.8 electron volts. क्या आएगा? 1.8 electron volts. Which option is correct? We have got these two equations again. Just I am summarizing. So what you can write? Corresponding to lambda 1, it will be 2v. Corresponding to lambda 2, it will be v. Correct? So in which case, which is slower? Obviously lambda 2. Why? Because lambda 2, the value is more. Got it? ठीक है? और कौन सा ऑप्शन करेक्ट आ गया? विच ऑप्शन इज करेक्ट? इट्स ऑप्शन ए, दैट्स एब्सोल्युटली करेक्ट फॉर दिस पर्टिकुलर क्वेश्चन. सो इफ यू हैव गॉट ऑप्शन ए, वेल डन, गुड जॉब, वेल डन गाइस. ओके ओके, यू गॉट इट? समझ में आ रहा है अभी तक सब कुछ? स्वास्तिका, कैप्टन जैक स्पैरो, कृष्णा, ऑल गुड नाउ? गेटिंग इट? चलो चले अगले क्वेश्चन की तरफ. Shall we go to the next question? हाँ, 2 electron volt approximately, तो which option you are going to go for? Near to 1.8, correct? चलिए आगे चलते हैं. Next question. The next question is, a metal plate of area 1 into 10 to the power of -4 meter square is illuminated by radiations of intensity 16 milliwatt per meter square. The work function of the metal is 5 electron volt. The energy of the incident photon is 10 electron volt, and only 10% of it produces photoelectrons. The number of emitted photoelectrons per second and their maximum energy respectively will be. Okay, so you need to find the number of emitted photoelectrons. क्या हो रहा है? There is a metal plate, ऐसा metal plate है कुछ. It is illuminated by some radiation intensity, इतना per meter square. तो total energy, of course you can find out this intensity times area, है ना? The total energy incident over this area you can easily find out. Work function of the metal दिया हुआ है, मतलब phi दिया हुआ है. Phi is given as 5 electron volts, no problem. The energy of incident photons, for the energy of one photon is how much? 10 electron volt. Energy of one photon is given as how much? 10 electron volt. But the thing is, only 10% of this is producing what? Photoelectrons. Only 10% of this is producing photoelectrons. See, you have total energy of the photons. Suppose there are 100 photons. ऐसे मान लेते हैं कि there are 100 photons. 100 photons की total energy, let us just assuming, okay? मान लो कि 1000 joules है. Just an example to make you understand this particular question. Just think that there are 100 photons and the total energy of this photon is equal to 1000 joules. If, or we don't know the total number of photons, but what we are saying is that the total energy over here is 1000 joules. If one photon has energy of 10 joules, तो बताइए कि कितने photons? How many photons are there? What you are going to do? You are going to say, okay sir, total energy, right? This is total energy divided by energy of a photon. Will give me what? Number of photon. But this is what? Number of photons. Correct. This is number of photons. But इसका कितना percent electron में convert हो रहा है? What percent? Only 10%. Get that clear. Only 10%. So only 10% means only this much. ये होगा क्या अपना? Number of electrons. Number of photons का only 10% is what? Number of electrons. समझ में आई बात? ये question, is this question clear now? है ना? Is this question clear now? हमको क्या निकालना है? Number of emitted photoelectrons. यही तो निकालना है. Total energy हम कैसे निकालेंगे? चलिए, let's solve it. कर दे solve, फटाक से. कर दे solve. Shall we solve? ठीक है. Total energy in 1 second. E total कितना होगा? E total will be how much? E total will be how much? I into A. Correct? I is given and where is A? A is also given. ठीक है? This will be total energy. Correct? Now, once you substitute this value, just keep it in joules. Later on, you can convert everything in at one go in terms of our electron volts, and you know how to convert it. कर दूं? चलो कर देते हैं यार. क्या इसका? This will be equal to how much? 16 into 10 to the power of -3 है ना? Milliwatt. 10 to the power of -3. Correct? Times what do we have? 1 into 10 to the power of -4, and this will be in terms of joule. कितना आ गया? कितना आ गया? Total energy will be how much? 16 into 10 to the power of -7 है ना? 16 into 10 to the power of -7 in terms of joule. ये आ गया total energy. Correct? What is the energy of one photon? एक incident photon का energy कितना है? 10 electron volts. Correct? Last में सब कुछ को electron volts में convert कर देंगे. So energy total divided by energy of one, or या फिर if you want you can also divide this with 1.6 into 10 to the power minus 19 और यहीं पे you can do it, right? So this will be energy of one photon, correct? This is what? This will give you number of photons, right? Number of photons. This will give you what? Number of photons. Once you have got number of photons, you know only 10% of this. If this is equal to 100, so इसका सिर्फ 10% is getting converted and ejecting your electrons. समझ में आएगी बात? Are you getting it? Only 10% of this is going and getting absorbed by these electrons, and only 10% of this total number of photons are coming out. तो ये तो आपके total number of photons आ गए. इसको क्या करना है हमको? Multiply करना है किससे? Total number of electrons के लिए E total by E. This is nothing but total number of photons times 0.1. यही तो काम करना भाई. Okay, all right. Just do it, and you get what? 10 to the power of 11, right? 10 to the power of 11 is the number of electrons. Now, at this point itself, you can stop. Why? You will say, sir, there are two things which are asked in the question. There are two things which are asked in the question. But when you look at the options, only one option says 10 to the power 11. So you need to even apply smartness over here, because you don't want to waste time in calculating the thing. Anyways, ऐसा कुछ है नहीं. You can easily calculate, you know, the total energy of incident photon minus 5. So 10 minus 5 will be 5 electron volt. एक line का और काम है. But what I would suggest, the moment you have got this, you are done. Okay? Why? Because when you look at the option check कीजिए. जैसे ही ये आ गया, you know that only possible option is option D. Got it? Okay, well done, Swastika. Good job. Okay, so whenever you are solving questions like these, take care of this part as well. How you can minimize your time. Okay? ठीक है? चलो. Let's move on to our next question. Next question. What is this question? The question says a laser light of wavelength 600 nanometer is used to weld retina detachment. I don't care what it is used for. Okay, I just want to solve the question. But it is used to weld retina detachment. If a laser pulse of width 60 millisecond and power of 0.5 kilowatt is used, the approximate number of photons in the pulse are, okay, take Planck constant as h is equal to 6.62 into 10 to the power of minus 34. Karo. Do it. Come on. Let's see who is going to get the answer first. कुछ नहीं है इसमें. There is, yeah, good evening. Come on, start doing it. Do it. There is a source of light. ऐसा मान लो there is some source which is giving you light. कोई ऐसा source है जहाँ से light आ रही थी, ठीक है? ओहो. There is some kind of a source. ऐसे बना दें. यहाँ से photons निकल रहे हैं. Photons are coming out. Okay, बहुत सारे photons आ रहे हैं. We need to count this number of photons. Okay, so this instrument is producing this much power, but it is operational only for how much time? 60 millisecond. Okay, it is operational for how much time? Only 60 millisecond. कितना power? 0.5 kilowatt. अब करो. Total energy कितना होगा? How much is the total energy? This is the power, and it is only on for how much? 60 milliseconds. तो इसमें से कुछ pulse निकलेगा. There will be a pulse that will be generated. So in this pulse, how many photons are there? That's the question. So you find the total energy, the power is given, the time is given, correct? Okay. So can I say the power, the total energy can be written as power times delta T? Yes. Power times where delta T is are 60 millisecond. Power is 0.5 kilowatts. Total energy मिल गया. And what is the energy of one photon? What is the energy of one photon? Wavelength is known. What is the energy of one photon? E is equal to hc by lambda y. So what is the total number of photons? This is energy of one photon. This is the total energy. Number of photons will be E total divided by E of one photon. खत्म है ना? Got it? Got it guys? समझ में आई बात कैसे करना है इसको? Did you understand what you have to do? The energy in one pulse will be how much? Energy in one pulse, let me write it as capital E. This is going to be equal to P times of delta T. Energy of one photon, pH, is going to be equal to hc by lambda. Okay? Number of photons is going to be equal to E by EPH. ठीक है? Which is P delta T by we'll have hc over here and lambda. Cool. Now substitute everything and approximately what do you get? What do you get? What do you get approximately as the value of number of photons? This will come out to be equal to 10 to the power of 20. Now see, understand the power of this formula. Actually what you have done. कोई एक torch है, there is a torch and you are shining that torch for some amount of time. Okay, shining that torch for some amount of time. You know the power of the torch. Okay, you know the power of that bulb. And if you're shining it for some amount of time, you can actually calculate how many photons have come out. Now just think how wonderful that is. Okay, got it? That's the beauty of this question. Okay, which has been demonstrated in terms of this laser pulse. So now you can actually calculate how many photons are coming out. Approximately, but yes, you can. For this question, the correct option was option A. Yes, the correct option is option A. Cool. All right. All good. समझ में आ रही है बात? Till now everything is crystal clear? Yes? चलो. One more problem. One more problem. The question is, a beam of light has two wavelengths. एक beam आ रही है that consists of two wavelengths. One is this much angstrom, another is this much angstrom. With a total intensity of 1.8 into 10 to the power of -3. ठीक है? Equally distributed among the two wavelengths. The beam falls normally on the area of 1 centimeter square of a clean metallic surface of work function 2.3 electron volt. Okay? Then what we have to find? Assume that there is no loss of light by reflection and that each capable photon ejects one electron. Okay? The number of photoelectrons liberated in 2 seconds. Now, if each photon is giving one electron, all you have to calculate is the number of photons in 2 seconds. That's it. Number of photons in 2 seconds. Now, immediately आप इसका total energy मत कर लेना. Okay? What I'll do is I'll not solve this question. I'll just give you a basic idea and you need to solve it yourself. Okay? Just give you a basic idea and you need to solve this yourself. Cool? First of all, find the energy associated with both of these values. That means I can write E1 is equal to Hc by lambda 1 and E2 is equal to Hc by lambda 2. Now, if this energy E1 and E2 due to both of these radiations, if any of them is less than the work function, because of that particular radiation, there will be no photoelectric effect. है ना? If it is less than the work function क्या था? Work function was the minimum energy required to take the photon out of this metal surface. Suppose there is a metal surface, इसमें मैंने एक radiation डाला, which is less than the work function, which is less than, so E is less than 5. Will any electron come out? We have discussed that in great detail in the last session yesterday, right? Nothing is going to come out. So you need to understand कि किसका लेना है and then which is capable of actually getting a photoelectric effect done for that particular surface of the metal. So this is the key. आपको ये value दे दिया and you need to find the energy and you need to check कि किस केस में photoelectric effect होगा और किस केस में नहीं होगा. ओके, इनफ हिंट गिवन, और उसके बाद तो फिर कुछ बचा ही नहीं, उसके बाद तो फिर इट्स ऑल इजी. So all you have to do is find the energy, and once you have found the energy, you will understand that what has happened in this case is that for one, let's say E1 will be equal to Hc by lambda 1. Once you substitute the value, this value comes out to be approximately equal to 2.5 electron volts. Okay, and when you substitute lambda 2, so this value is greater than the work function, which is 2.3, which means because of this electrons are going to come outside. Yes, so photoelectric effect, right? This is going to facilitate what? Photoelectric effect. E2 Hc by lambda 2. Once you find this value, it comes out approximately around 2, which means 1.99, I think, in terms of electron volts, which is less than this. Okay, Captain Jack Sparrow, you are asking, does light travel in form of wave or photons? So you see, it's slightly difficult to answer in such a small bit of time, but still I'll try. Just imagine that you want to transfer water from one point to another point, point A to point B. This is your friend. You are at point A and your friend is at point B, okay? And you want to give a packet of water to him. You have got a packet of water, but this is so fragile that the moment it hits the hand of your friend, it's going to just break apart and it's going to flow like that. Light also behaves in the same way. So what happens, you have got this packet and it is thrown like this. The moment it interacts with matter, it appears to be behaving like a wave. But while it is traveling, it travels as photons. Alright, somewhat. In a limited sense, I'm just giving you an example that what is happening. All these photons are coming, hitting and spreading out. Again spreading out in terms of photons. Alright, are you getting this? Because the idea of photoelectric effect is itself that, you see, you cannot have an electron knock off instantaneously if it is not hit by a photon like this. So photon has to be a particle. Got it? So in limited sense, I have given you the answer, but yes, it's in more detail. I wish I had more time, we could have done that. Okay, anyways, for this particular question, you need to find out yourself. And once you have found out that only because of E1 there will be photoelectrons, now you know the energy, total energy, and you know how to calculate the number of photons. Once you have calculated, because that will be powered by energy of one photon. So once you substitute that, you get the total number of photons. Total number of photons, for every photon there is an electron. So in 2 seconds, how much it is going to be? So total number of photons times 2, because this is number of photons in 1 second. So number of photons in 2 seconds will be twice of this, and if it is twice of this, this is also equal to number of electrons. Why? Because for every photon there is a electron which is associated. Cool. So 9 into 10 to the power 11 is what you get, and the correct option for this particular question is option B. Okay, so yes, I hope you had a wonderful session today in discussing all these previous year's questions, and I hope you enjoyed the session, you learned something from this session. I'll see you again, we'll meet again with more interesting concepts, with more interesting topic and more interesting questions. Till then, this is your friend and mentor Mrinal signing off. Keep learning, keep thinking.